in this video we're going to solve rational equations. A rational equation is an equation that's going to have some ratios in it or fractions. And so the first thing you want to do is you want to ask yourself how many terms are in the equation. If there are only two, you're going to take this route. If there are more than two, then you'll take this route. So let's take a look at if there's two terms in the equations. Then you're going to set it up as a proportion, and cross products of every proportion are equal to each other. For example, if you had 1/2 equals 4/8, you can take a look at the cross products and they're equal to each other. So when you have two terms, you will set them up as a proportion. Take their cross products. You also want to check for extraneous solutions because they are prevalent in rational equations. If you have more than two terms, then you're going to take this path here. You're going to start by solving the equation, solve by clearing the equation of the denominators. That is done by determining the least common multiple, multiplying every term by the least common multiple, and rewriting the equation without fractions. Once again, you will check for extraneous solutions. So let's take a look at a few examples. In this first example, you can see I have two terms, and a term again is this whole package is one term, and this is another term. So the first thing you want to do is you want to make sure that they're set equal to each other. And now you can take cross products. So I'm going to go ahead and multiply 4 times x squared minus 1, which is going to give me 4x squared minus 4. And then I'm going to multiply 12 times 3x plus 3. And this gives me 36x plus 36. You can see now that we have a quadratic term, which means that we're going to solve it using a variety of different methods you can use. But let's just try solving it by factoring first. So what I'll do is I'll subtract off the 36x and the 36 from the right-hand side, bring it over here to the left-hand side. And when I do, I'm going to have 4x squared minus 36x minus 40 equals 0. As I look closely at this, I want to make sure that there's no GCF, because if I can factor out a GCF, it'll make the factoring trinomial much easier. So as I look down the line, I can see that 4 is a common factor to every term. Now what I can do is factor it. I want factors of 10 that equal 9. That's going to be minus 10 and plus 1. And now that'll give me x is equal to -1 and x is equal to 10. The next thing you want to do is you want to check your answers. Now I've already done this in this problem, so let's just follow along. When I plug in the number 10, you can see that I've just taken out x, plugged in 10. I get 4 over 33. Done the same thing over here. Doing the same thing over here, I get 12 over 99, which reduces down to the same fraction. So 10 does check out. Next, let's check -1. When we plug -1 into this equation, we're going to get the undefined fraction on both sides. So -1 is disqualified as an answer as a result of this problem that occurred in the check. Okay, let's take a look at another example. And this time we have more than two terms, excuse me. We've got a total of 3 terms. So the path that we're going to follow is the one that's on the right on your flow chart. So what we want to do is we want to determine what the least common multiple is. Now the least common multiple is also known as the least common denominator. So if I were adding or subtracting these fractions together, I'd want to find a common denominator. We're going to try to find the least common multiple so that we can clear the equation of the fractions. That is determined by looking at each piece and seeing what I have in each piece. In this case, I have a 3x, a 3, and an x squared. What it's going to take to cancel out each of these terms is a component of each one. So I need a 3 to cancel out this 3 and this 3. I need an x to cancel out this x, but I need an additional x to cancel out this one over here. So the least common multiple this time is 3x squared. You're going to multiply each term by the least common multiple. As a result of this, what's going to happen is the the denominators are going to cancel out. So you'll be left with an x right there. Here you're going to be left with an x squared, and for this one you'll be left with just the 3. Next, what you want to do is you want to rewrite the resulting equation. So you have this x, which gives us an 11x minus an x squared is equal to a negative 12. Once again, we have a quadratic term, which means we need to solve it using quadratic methods. So I'm going to set everything equal to 0. We always like that quadratic term to be positive, so I'm going to add it to this side. And as I do, my new equivalent equation is going to be x squared minus 11x minus 12 equals 0. And again, all I did was add the x squared over here, subtract the 11x here. Next, we'll try factoring. Factors of 12 that equal 11 are minus 12 plus 1. So my answers, or my solutions to this, are x is equal to 12 and x is equal to negative 1. Once again, what we would like to do is we need to check both of those answers to make sure that they check. When I plug in the negative 1 into this sentence, I get negative 12 over 3 is equal to negative 4, and that does check out. Finally, the number 12, when I plug in the number 12, I get 11 over 36 minus a third is equal to negative 4 over 144. Again, trying to find some common denominators here and reducing this fraction down, I get the same answer on both sides. So both of these answers did check. So that's how you do these types of questions. I'd like for you to continue to try to do the rest of these for your homework and do the best you can. We'll see you in class.